Solving a system by elimination. This is the third option we have when we have to solve a system of equations. And if we can add vertically, remember vertically means up and down, sometimes we can easily eliminate the x or the y within the equations. So just highlighting once again, we're going to be combining vertically within equations. Sometimes we call this method a linear combination. So if it's a linear combination, it's going to be a combination of lines. And we can see that in this quick example. If we have 3x plus y equals 6 for the first equation, and 5x minus y equals 10 for the second equation, important here, all like parts must be aligned vertically. So the x's are over the x's, the y's are over the y's, the equal signs are over each other, and the constants are over each other. What we see here is that the y terms have opposite coefficients. And if we have opposite coefficients, when we combine these two lines, then the y's are going to cancel. Remember, we're going to add vertically in order to eliminate an x or a y within the equations. So we're going to keep the same problem, and we're going to see how this is done on this next page. So here we go. 3x plus y equals 6, 5x minus y equals 10, x's are lined up, y's are lined up, and the constants are lined up. We're going to add vertically, and then we will solve for the remaining variables. So here goes. 3x plus 5x is 8x. A positive y and a negative y, they have opposite coefficients, so they cancel. 6 plus 10 is 16. So now we've got 8x equals 16, and this is all that remains, making it easy to solve for that remaining variable x. If 8x equals 16, when we divide both sides by 8, we get x equals 2. So when we get x equals 2, we can now finally use substitution to solve for the alternate variable. So we found out what x is. Now we're going to substitute this x value back in to solve for y. And you can choose either equation. It doesn't matter. I'll go with the first one. 3 times x. We just found x to be 2 plus y equals 6. 6 plus y equals 6 minus 6 minus 6, y equals 0. So we have our x and we have our y. Remember, solutions to systems come in the form of x, y. So our solution to our system is 2, 0. Now remember, we want to check our work here. So to check our work, the xy solution should make both equations true simultaneously. So let's take our point and let's plug it into the equation that we did not use on the last part of the problem. We used the first one, so let's go to the second one. 5x minus y equals 10. Let's plug in this solution and see if it checks. We can squeeze that in right there in the checkbox. So 5 times x is 2 minus 0 equals 10. 10 minus 0 doesn't equal 10, so it checks. So we add vertically to cancel out a variable and then solve for the remaining variable. We use substitution to solve for the variable that was canceled. And then we check our work, plug in your xy. That solution should make both equations true simultaneously. That is elimination. So what if neither variable will eliminate? Well, we've got a 5 and a 4, a 3 and a 2. So sometimes we need to use multiplication to help things along. So you can make a choice here. I am going to choose to eliminate the x's. So if I want to eliminate the x's, I need to create a situation where I have opposite signs on the x's. So opposite signs and opposite coefficients on the x's. So if I have positive 5x and a positive 4x, I will multiply the top equation by negative 4, and I will multiply the bottom equation by positive 5. So let's take that first equation and let's move it down. I'm going to use the distributive property here, and I will be multiplying every term in that equation by negative 4. So negative 4 times 5x is negative 20x. Negative 4 times positive 3 is negative 12y. Negative 4 times 2 is negative 8. So there is my newly transformed equation. I'm going to do the same thing with the second equation, except this time I'm going to be distributing a 5 to every term in the equation. So 5 times 4x is positive 20x. 5 times 2y plus 10y. 5 times 10, 50. And now, by using multiplication, I've now got opposite signs and opposite coefficients on my x's. So when I do the combination of the two equations, the x's are going to cancel. A negative 20 and a positive 20 cancel. Negative 12 plus 10 is negative 2y. Notice my x's are lined up, my y's are lined up, equal signs are lined up, and the constants are lined up. Negative 8 plus 50 is 42. So from here, I can now solve for the y by dividing both sides by negative 2. So I end up with y equals 42 divided by negative 2 is negative 21. So I can take my negative 21 and I can use the substitution property again. Choose either equation, it doesn't matter. I think I'll just go with the first one. So 5x plus 3 times y is negative 21, equals 2. So from here, let's solve for x now. Follow order of operations, so multiply first. So 5x minus 63 equals 2, plus 63 plus 63. 5x equals 65. Divide by 5, divide by 5. X equals 13. So we've got our solution. Remember, the solutions come in the form of x comma y. So our solution is 13 and negative 21. So this is a good example to remind you of why the graphing method doesn't always work. Or it works, but it's not always easy. This one would not fit very well on our graph paper because it goes over 13 and down negative 21. Let's finish it off here with x plus 3y equals negative 14 and 2x minus 4y equals 32. This is another one where we don't have opposite coefficients on the x's or the y's, so we need to force that to happen. You can choose the x's or the y's, but in this particular problem, it appears that the x would be the quickest way to make something cancel. So if I multiply this top equation by negative 2, this time I'll move to the right, using the distributive property. Negative 2 times x is negative 2x. Negative 2 times 3y is negative 6y. Equals negative 14 times negative 2 is 28. Then the bottom does not need any adjusting at all because we've now got opposite signs and opposite coefficients on the x's. So now we can do the linear combination. So negative 2x, positive 2x, they cancel. A negative 6 and a negative 4 is a negative 10y. 28 plus 32 is 60. Divide by negative 10, divide by negative 10, y equals negative 6. So there's our y. Let's plug it back in. Remember, you can plug it in the top or the bottom equation. It doesn't matter. I'll go with the bottom. 2 times x minus 4 times y, which is negative 6, equals 32. So 2x plus 24, I'm multiplying because of order of operations here. Minus 24, minus 24. 2x equals 8. Divide by 2, divide by 2. X is 4. So there's our x, there's our y. That means that our solution in xy form is 4, negative 6. Let's give it a quick check. We use the bottom equation. Let's plug it into the top. So is, check it right up at the top. So is 4 plus 3 times negative 6 equal to negative 14. This is 4 minus 18, and that indeed is a true statement. So yes, our solution checks. That is solving systems by elimination.